Some people have likened me to Bobby Fischer, not in terms of chess ability, but in terms of temperament. Anyway, we have a chess piece here. It's a king, effectively, and we have some x-planes cut, and we can see the velocity magnitude, so effectively just the wake. And we see that the chess piece itself, to begin with, the wake is quite representative of the chess piece in terms of its geometry. But even going just a little bit downstream, like even two chess pieces downstream, the wake becomes blobby, which means that it's pretty much just caving in on itself based on probably the vortices coming off of it. And then it gets quite unsteady downstream as not only the flow breaks down, but also that the flow coming off of the chess piece is unsteady to begin with because it is a bluff body. So now this is a y-plane, which shows us the unsteadiness that we're looking at in the x-plane, just in a bit better view. And we can see that there's not really there's a unsteadiness coming from the z direction. So there's like flow coming over the top, separating, and then it sort of rolls up a little bit into a vortex. We'll see another plane in a little bit showing the vortex. And then from the bottom, we get this asymmetry in this shedding going on. And we can see that the wake is quite large, and there's a lot of recirculation coming back. Like the flow pretty much travels 2 or 3 chess pieces upstream, and then gets caught back up in the rest of the flow and goes downstream. In terms of the wake coming off of it, it breaks down fairly quickly after the initial main wake bit. So let's look at the vorticity. So now this is the same plane, but now with the vorticity colored, and it effectively just shows the vorticity. There's nothing else, none of the little minor little bits, just the major bits. And we can see that there is a fairly coherent shedding coming off of this. The top part seems to be a bit stronger in terms of the vorticity magnitude than the bottom vortex. So there's some sort of asymmetry going on there. And then they travel downstream quite quickly and break down very quickly. So now we have 2 z-planes, one at the top and one halfway through the chess piece. And I just want to see the one at the top because it is a little bit off the top of the king, but there's still a little bit of wake there, so it shows the 3-dimensionalness there. But also the plane that's going through the middle of the chess piece, this shows unsteadiness and periodic shedding as well. So the shedding pattern that was coming off of this is 3-dimensional because this is a 3-dimensional bluff body. Now, because it is a fairly simple 3-dimensional bluff body, the shedding patterns are still noticeable, they're identifiable. When you get to more complex 3D shapes, often you just get like a bunch of random crap coming off of it that you can't really isolate different shedding frequencies of it. But from here, you can see that there is quite a repeatable pattern that we can see. Now, that's the exact same view, but with the vorticity colored now. And we can see that the vortices being shed are very coherent. So you can see these little pockets of highs, and they are very noticeable when we go to the slow motion. So that's in the simulation. Make sure to like, subscribe, and tell me what you think your favorite chess piece is. And if you want to get better at CFD and or theory, check out our courses and link in the description. And I'll see you in the next simulation. Peace out, amigos.